Okay. So electrostatic potential means strength of electric charge. Strength means how strongly or weakly it attracts or repels another charge. And in capacitance, we study how much charge. Yes, can conduct a whole. Okay. So potential and its relation with field. So we have read about electric field. The word electric field means the space. So it is the space around the charge where its effect can be experienced. Okay. Suppose we have a source charge. So this is the field. These arrows indicate the field of source charge. So if a test charge enters the field of source charge, then force will be experienced by the test charge, and that force can be attractive or repulsive. That depends upon the nature of charges, right? So see, in electric potential, see, suppose we have a situation where we have a source charge. So you can see here we have plus Q charge, and this charge is test charge. So this charge is not in the field of given charge, because this test charge is not in the field of given charge. So it will not experience any kind of attractive force or repulsive force by the source charge. But once it enters the field of source charge, then it will be repelled. And see, so ये test charge है, ठीक है? At this position, at this particular point, it is not experiencing any kind of force. But once it enters the field of source charge, then this test charge will experience force. So this source charge will exert force on test charge. Now, if this charge wants to stay at this particular position A in the field of given charge, then this test charge has to do some work against the electrostatic force exerted by source charge. Okay. So to maintain its position in the field of source charge, this test charge has to do some work against the electrostatic force. Yes. Okay. A small amount of work will be done by the test charge. Okay. So net work done is, and this is negative. Why negative?
Because it's against it.
Because this work is done against the electrostatic force, and therefore it is negative, because it is against the electrostatic force. Okay. Suppose this charge is somewhere here and it covers a small displacement dr. So small amount of work will be done for small displacement, and net work done, total work done, we can find out by integrating it. And why negative sign? Because the angle between them is 180 degree. F is acting in this direction, and dr, this r is acting in the opposite direction. So they are in the opposite direction. So theta is 180 degree, and cos 180 degree is -1. Okay. See, in case of positive charge, both charges were positive. In the previous slide, both the charges were positive. Okay, and this was the field of the source charge. So when a test charge enters the field of given charge, why would a test charge enter the field of given charge? Some external work, external force is applied on the test charge to make it move, and so that it enters the field of given charge, right? So some external work has been done. And due to this external work done, this test charge goes to the field of the source charge. Now, when it enters the field of the source charge, it experiences repulsion. ठीक है, उसको ये source charge repel कर रहा है. So there is a electrostatic force acting on the test charge by the source charge. So there are two kinds of forces you can see. One is external force, and second is electrostatic force. This external work is in the direction where the charge is moving, this external force is in the direction of displacement, right? This external force is in the direction of displacement, while this electrostatic force is opposite to the direction of displacement, right? इलेक्ट्रोस्टैटिक फोर्स जो है वो डिस्प्लेसमेंट के अपोजिट डायरेक्शन में है, और एक्सटर्नल फोर्स जो उस पे एक्सर्ट हो रहा है वो डिस्प्लेसमेंट की डायरेक्शन में, ठीक है? तो चार्ज, दिस टेस्ट चार्ज एनी हाउ मैनेजेस टू मेंटेन इट्स पोजीशन इन द फील्ड ऑफ गिवन चार्ज, ठीक है? नाउ बिकॉज दिस इज रिपल्सिव फोर्स, तो वो एनी हाउ मैनेज कर रहा है कि हाँ मैं एडजस्ट कर लूं, यहाँ पे रह जाऊं, ठीक है? बट व्हाट इफ वी हैव a negative source charge and this charge is positive, then we can easily move this charge because there is attraction, no force is required. Is there any force required? अपने आप से move करेगा? External force is required to move it. Okay, let's apply some external force on this to move it. Okay,
फील्ड के अंदर स्टे पे रहने के लिए नीचे.
see, so we have applied external force on this charge to move it, and it enters the field of the given charge. Now you can see this is negative and this is positive, so I think there should not be any problem. Is there any problem?
No.
नहीं है, पक्का पक्का नहीं है. See, let the distance is 2 centimeter, and charge, this test charge wants to stay at a distance of 2 centimeter only. But this source charge is pulling this test charge towards itself. अब ये charge क्या करे? This poor charge, the test charge, cannot stay at a distance of 2 centimeter anymore because source charge is very big. ठीक है ना? इस पे जो फोर्स एक्सर्ट करेगा ये बहुत ज्यादा एक्सर्ट करेगा, और ये जो टेस्ट चार्ज है इसको 2 सेंटीमीटर के डिस्टेंस पे ही रहना है, ठीक है? इसको आगे नहीं आना है, बट जो टेस्ट सोर्स चार्ज है वो तो पीछे जा रहा है, नहीं नहीं आओ पास में, और आगे भी आ सकते हो आप, वो उसको वेलकम कर रहा है, अलाउ कर रहा है. तो अब अपनी पोजीशन को मेंटेन करने के लिए दिस चार्ज हैज टू अप्लाई फोर्स अगेंस्ट द इलेक्ट्रोस्टैटिक फोर्स. Okay, because now this time electrostatic force is acting in this direction, but this charge has to apply force in the opposite direction to maintain its position in the field of source charge. Again, these forces are equal and opposite. Yes, in the previous case, when both the charges were positive, then electrostatic force was acting in this direction, ठीक है? And this external force was acting in the opposite direction. But in this particular case, electrostatic force is acting inward and external force is acting outward. Okay, clear? Again, the work will be done against the electrostatic force. Work will be done against the electrostatic force, and this work done is minus F dot dl. Okay. Yes, same. This work done is nothing but electrostatic potential energy. It is equivalent to electrostatic potential energy. Okay, please write this. Right. So electrostatic potential at any point in an electrostatic field is the work done in bringing a unit positive charge from infinity to that point. So our Q naught is unit positive charge. It is a test charge. So amount of work done in bringing a unit positive charge, Q naught plus 1 coulomb, unit positive charge from infinity to a point in the field of source charge. This we had discussed. And we had a source charge and the field of source charge and a test charge outside the field, and then we move the test charge to the source of field of source charge. कितना amount of work done होगा उस test charge को उसके field में लाने के लिए, यूनिट पॉजिटिव चार्ज को सोर्स चार्ज के फील्ड में लाने के लिए कितना अमाउंट ऑफ वर्क डन होगा, दैट्स इलेक्ट्रोस्टैटिक पोटेंशियल. It is numerically equal to work done or electrostatic potential energy per unit charge. Okay, if our charge is not unit positive, then we divide it by Q, W upon Q. Then we get electrostatic potential. It is a physical quantity which determines the flow of charge from one body to another body. Charge flows from a body at higher potential to a body at lower potential. Okay, so it governs the flow of charge between bodies and it is a degree of electrification of a body. Degree of electrification, the meaning of the word electrification is charging. Okay. And this is denoted by V. V is equal to W by Q. V is electrostatic potential, W is work done, and Q is the charge which is moved from infinity to a point, yes, in the field of source charge where we have to find electrostatic potential, and this U represents electrostatic potential energy. So electrostatic potential energy upon charge. Okay, so U is electrostatic potential energy, V is electrostatic potential. What is the unit? It's joule per coulomb or volt. Unit of work done is joule and that of charge is coulomb, so it is joule per coulomb or volt. Dimensional formula is, you can find dimensional formula, right? It's very easy to find dimensional formula. How will you find? See, what is work done? Work done is, tell me.
Force into displacement.
It is force multiplied by displacement. Dimensions of force, MLT minus 2. Dimension of S is L, and dimension of charge. Charge is current into time.
80.
So it's 80. Okay. So you can simplify it and you'll get this dimension of electrostatic potential. Easy? Please write this in your notebook. Yes. So electrostatic potential represents status of charges, status of forces, status of kinetic energies, none of the above. It represents status of charges. Status of charges. Electrification इस पे depend करता है. Status of charges means कितना strength है उसका कि वो उसमें withstand कर सकता है. See, electrostatic potential का मतलब क्या होता है? Electrostatic potential मतलब strength of charge. Strength of charge का मतलब कि कितना strongly या weakly attract या repel कर रहा है या फिर कितना withstand कर सकता है. वैसे उसके field में भी है अगर तो कितना वो उसको hold कर सकता है. Right? Electrostatic potential is a dash quantity. Vector, tensor, scalar, none of these. Yes, it is a scalar quantity. It is work. Yes. Okay, suppose we have a source charge Q and a test charge is placed, unit positive charge is placed outside the field of source charge at infinity. Okay, and we want to move this charge. If we move this charge Q naught from infinity to some point A, then we can easily find electrostatic potential at this point. Okay, so electrostatic potential at this point is work done in moving this unit positive charge, the test charge, from infinity to point A is the electrostatic potential at A. And if we want to move this charge to B, again we can find electrostatic potential at B. Work done in moving the charge Q naught from infinity to point B is electrostatic potential at B. Okay. So these are two different positions in the field of source charge. So as you can see here that B appears closer to the charge than A. So where the field, electric field is stronger. Electric field strength kahan hai hogi? At B. at B field is stronger. तो जहां पे ज्यादा अमाउंट ऑफ वर्क डन करना पड़ेगा Q नॉट को कहाँ करना पड़ेगा, जितना वो क्लोज जाएगा, जितना टेस्ट चार्ज सोर्स चार्ज के क्लोज जाएगा उतना ही ज्यादा उसको वर्क डन करना पड़ेगा अपनी पोजीशन को मेंटेन करने के लिए, क्योंकि उतना ही स्ट्रॉन्ग अट्रैक्शन और स्ट्रॉन्ग रिपल्शन वो फेस करेगा. Electric field intensity is inversely proportional to square of distance. Even electrostatic force is inversely proportional to square of distance. So if we decrease the distance between the charges, then there is strong force or strong electric field intensity, right? So if this charge Q naught moves to point B, then it has to face stronger force, electrostatic force or electric field intensity due to the given charge, the source charge. More work has to be done by the test charge at this point. So at this point Q naught, B, more work has to be done by the test charge. B वाले केस में टेस्ट चार्ज को ज्यादा वर्क डन करना पड़ेगा because it is closer to the source charge. So electrostatic potential at these 2 points is not same, it is different. So electrostatic potential is different.
It is greater at B and lesser at A.
Yes, it is greater at B and less at A. Okay. So suppose the charge is initially at A and this charge wants to move to point B. Then, yes. Okay. So this charge is initially at A and this charge wants to move at B. तब कैसे हम इलेक्ट्रोस्टैटिक पोटेंशियल, अब क्या निकालेंगे हम, पोटेंशियल डिफरेंस. क्या फाइंड करेंगे,
Potential difference.
Potential difference. See, यहाँ पे potential is VA and here potential is VB.
So VB minus VA हो जाएगा.
Yes. So what is VA? Work done in bringing the charge from infinity to point A is VA. So we don't need to write Q naught because it is unit positive, but you can write if you want to. It's +1 coulomb unit positive test charge, right? And work done in moving the charge from infinity to point B is VB. Okay. Suppose let's take an example. Here the charge has to do a work of let's say 10 joules. And if this charge goes to point B, it has to do work of 12 joules. Then what extra work has to be done by the test charge to go from A to B? 2 joules extra. है ना? So it has to do the work of 2 joule. Extra work has to be done by the test charge to move from A to B. Okay? थोड़ा समझ आ रहा है?
अच्छा खासा.
Okay, so we can find work. See, work done in moving the charge from A to B. Okay, this is the potential difference. This is the potential difference, and this is VB minus V. Okay, this is VB minus VA. We call this potential difference. Please write this in your notebook. See, for the sake of our convenience, we choose electrostatic potential energy as 0 at infinity. Okay. So potential difference between any 2 points in electrostatic field is defined as the work done to transfer unit positive charge from one point to another, or difference of electrostatic potential energy between the points per unit positive charge. So this is how we write potential difference. Okay, V2 minus V1 or VB minus VA we had written now. So it's dV upon W by Q, or change in electrostatic potential energy by Q. Please write the formula and then we'll move to the next question. Written. Now we have a question based on this. The potential difference between 2 points is 10 volts. Potential difference between 2 points is 10 volts. So we can write V2 minus V1 as 10 volts. So how much work will be done in carrying a charge of 2 microcoulomb. 2 microcoulomb is 2 into 10 power minus 6 coulomb from one point to the other. So we have to find work done. How will you find work done? V2 minus V1 is W by Q. So this implies W is Q V2 minus V1. Okay, put the value. It's 2 into 10 power minus 6 into 10. So the answer is
2 into 10 to the power minus
2 into 10 power minus 5 joules. Write this answer in your notebook. So electrostatic potential energy is the amount of work done in bringing a charge from infinity to a point in the field of given charge. And if we talk about per unit charge, then unit positive charge, then we call it electrostatic potential. So potential is work done upon charge. What is electrostatic potential? It is the amount of work done in bringing a unit positive charge from infinity to a point, some point P in the electric field of given charge. If we say unit positive, then it's electrostatic potential. And if we talk about the work done, just work done, and do not consider the amount of charge, then it's electrostatic potential energy. Okay. Now draw a coordinate axis. बिल्कुल कर सकते हैं, रिमोट आपके पास ही होता है, मैंने अपने हाथ में कंट्रोल रखा ही नहीं हुआ इसी का. ठीक है. Let the source charge is placed at origin, and we have this small charge at some point A. Okay, this small charge is at some point A. Now the distance of this small charge from the source charge is, let's say, vector R1. Okay. And now we are going to move this charge to some other point B in the field of given charge. To a point B, let's say somewhere here. This point B lies here. Okay, so this charge from A, it moves to point B following this path. Okay, and it reaches point B, and this point B is at a distance, let's say
R2,
vector R2 from the source charge. Okay. Now force exerted on this charge is Q into vector E. Yes, this vector is the electric field of capital Q, source charge. Okay. Now let's consider a situation where when the charge was at some point P. So at this point P, because charge is moving from point A to B na, so we'll consider an intermediate situation. बीच में कोई भी ऐसे उसके पाथ में हमने एक पॉइंट कंसिडर किया कि चार्ज जो है ए से निकला हुआ है, बी पे पहुंचा नहीं है, पहुंचने वाला है, और रास्ते में वो पॉइंट पी पे पहुंच गया, स्टेशन आ गया उसके पी पॉइंट पे. ठीक है. So at this point P, force will exert on this charge. ठीक है, क्योंकि ये फोर्स की डायरेक्शन को रिप्रेजेंट कर रहा है. Okay, so force will exert on this charge, and this force is QE vector. Okay, and suppose, अच्छा हम क्या करते हैं फिजिक्स में, पहले तो हम एक इंटरमीडिएट सिचुएशन पोजीशन लेते हैं जो ना उसकी इनिशियल पोजीशन है ना उसकी फाइनल पोजीशन. Every time we do like this, and then we say suppose it covers a small displacement and from P it goes to point Q. This is how we do the problems in physics, है ना तो हम इनिशियल पे फोकस करते हैं ना फाइनल पे जाते हैं, हम बीच में कोई सिचुएशन कंसिडर करते हैं कि अभी P पे पहुंचा और P के बाद स्मॉल डिस्टेंस कवर किया उसने Q. Yes, you can call it ds or dr. Okay, so let this displacement be dl. Okay, this is the small displacement. So small amount of work will be done in moving from point P to point Q. Small amount of work will be done by the charge, right? And this small amount of work done can be written as dW, and it is equal to vector F dot dl. Okay. Now what is F? See, this work done is against the electrostatic force. So we'll put a negative sign. And one more thing. See, we are taking this displacement, right? This displacement. And force is acting in this direction. So we will take that component of dl which is in the direction of force. Okay. Let's see. So it's QE dl cos theta with a negative sign because they are acting in reverse direction. And this dl cos theta is that component of displacement which is in this direction, in the direction of force. Okay, so this can be written as dr, so minus QE dr. So this is a small amount of work done when the charge covers a small displacement in the electric field of source charge. Okay, so small displacement, small work done, and if you want to find the total work done, the net work done, then total work done, yes, बिल्कुल integrate कर देंगे. Total work done in bringing the charge from A to B is WAB, and we'll integrate this. Minus Q outside, in the bracket we'll write A to B vector E dot dl. Or we can write minus Q. If we want to write in terms of R1 and R2, then we'll consider E dot dr. Okay. Now what is E? How do we write E? E is the electric field of given charge. E is the electric field of given charge. So E is nothing but KQ by R square. What is R? This is vector R. This position is vector R. Okay. बिल्कुल. So it is minus KQ. Yes, KQQ. R1 to R2. 1 by R square dr. Okay. So we'll use the formula x and dx here. What is the formula? It's xn plus 1 upon n plus 1 plus c. C is the constant of integration. But here we have limits. So we will not write C. Okay. Should I clear this side? Okay, so this work done in moving the charge from A to B is minus K Q Q. हाँ जी बताओ भाई 1 upon R square है R की power minus 2 plus 1 upon minus 2 plus 1. What will you get? Minus 1 by R. Using this formula you'll get this. So it's minus 1 by R. Now put the limits, write the limits R1 to R2. Minus minus. Minus minus plus. So it's K Q Q. First we write the upper limit. Then put a negative sign and now write the lower limit. This is the work done. Okay. And this work done is nothing but electrostatic potential energy